Did you know that Mars and Venus are our closest neighbors in the solar system? When Mars is in a particularly favorable position, it's only 55.6 million kilometers away from us on its elliptical orbit. At this distance, we can see it as a bright red dot in the night sky with the naked eye. Astronomers have been observing strange processes on Mars since the 17th century. Its changing colors and Earth-like surface features led early scientists to speculate that life might exist there. If you enjoy our videos, please support us with a thumbs up. Subscribe to the Space Bureau and stay tuned for more exciting content coming your way. Mars, our neighboring planet, has been a focal point of exploration, second only to the Moon in terms of human scrutiny. Over 50 space probes have ventured towards the Red Planet as part of international efforts. Among the pioneers were NASA's Viking 1 and 2, launched together in 1976. Viking 1 operated successfully until 1982, while Viking 2 transmitted data back to Earth until 1980, marking significant milestones in Mars exploration. In the 1990s, Mars Pathfinder made history as the first robot to land on Mars, setting the stage for future missions and scientific breakthroughs. More recently, the Mars rover opportunity, active from 2004 to 2019, and its predecessor, Curiosity, operational from 2012 to 2020, undertook extensive research missions on Mars. These rovers have reshaped our understanding of the Martian landscape and provided valuable insights into its geological history. Since Mars is easily observable from Earth, ancient astronomers first noted its seasonal changes, particularly at the poles, where carbon dioxide geysers and dark dust form with the onset of spring, creating distinctive cloud formations. These settle back onto Mars' surface, altering its appearance with spots and fan-like structures. By the 19th century, advancements in telescopes offered clearer views, leading astronomers to interpret these color changes as signs of shifting vegetation zones. Speculation grew that Mars might harbor Earth-like life forms, fueled further by William Whewell's 1854 theories of Martian oceans and lands. In 1877, Giovanni Schiaparelli's discovery of Martian canals, actually Martian troughs, sparked imaginations further, mistakenly fueling beliefs in structured water channels and fostering notions of intelligent life on Mars. This fascination culminated in H.G. Wells' 1897 novel, The War of the Worlds, which described a Martian invasion of Earth, intensifying both curiosity and fear of Martians. Since then, these early beliefs, fueled by literature and scientific speculation, have deeply influenced our collective imagination regarding Mars and its potential inhabitants. About 80 years later, humanity embarked on an unprecedented journey by sending the first mysterious space probes to Mars. Back on Earth, anticipation was high, with people eagerly awaiting answers to long-standing questions about Mars' potential for life. Prior to these missions, scientists had even attempted to establish radio contact with hypothetical Martian civilizations, but received no response. Then, in July 1976, the Viking 1 mission delivered groundbreaking images from Mars' orbit. As exploration progressed, Mars revealed itself not as a watery world teeming with life, but rather as a dry and barren desert planet. Yet, the images sent back to Earth sparked intrigue. The most notable was the face of Mars, a rock formation in the Cydonia region that eerily resembled a human face. Alongside it, the orbiter captured images of pyramids and rectangular structures, likened to an Inca city by scientists. These tantalizing hints of artificial structures prompted NASA to dispatch the Mars Global Surveyor in 1996 for a closer look. However, nearly 2 years later, hopes were dashed. High-resolution photos revealed that the face was simply a natural, shapeless rock formation. Similar natural processes explain the other anomalies, dispelling notions of ancient Martian civilizations. Despite this, the Mars Global Surveyor marked a significant milestone as the first probe dedicated to the search for extraterrestrial life, reminding us of our enduring fascination with the red planet and the mysteries it still holds. Despite repeated debunking of images like the face of Mars as optical illusions, ufologists persist in searching for signs of extraterrestrial life on Mars. Online forums are rife with images purportedly captured by recent space probes. Some enthusiasts claim to have identified giant bones or new Martian faces in these images, perpetuating the fascination with potential Martian life forms. The question of whether there is water on Mars or not occupied the researchers, as did the question of clarifying the apparent structures. Initially, it seemed clear that Mars' thin atmosphere and low air pressure made surface water impossible. However, suspicions arose that water might exist in deeper rock layers, potentially forming underground lakes or oceans. In 2010, a surprising discovery by a student revealed seasonal flows of liquid salt water in Mars' Hale crater. The origin and periodic appearance of these flows remain a mystery, suggesting Mars might push liquid from its interior when heated, akin to sweating. In 2018, the European Mars mission, Mars Express, definitively confirmed the existence of liquid water on Mars. Using georadar, scientists detected a 20-kilometer wide lake beneath a 5-kilometer thick layer of ice at the planet's south pole. This discovery reshaped our understanding of Mars' history, suggesting it once had a warm, humid climate with lakes and rivers over 3.6 billion years ago. This ancient water presence likely shaped Martian surface features before the planet eventually lost its atmosphere and dried up. In the 1970s, Viking 1 initially captured images suggesting remnants of organic structures on Mars. However, subsequent laboratory tests revealed that similar structures could also form through purely chemical processes. It's widely accepted that Mars cannot support humanoid beings or complex life forms. Current research focuses on finding microorganisms like unicellular organisms, primitive algae, or bacteria, which could have been the precursors to life as we know it on Earth. A glimmer of hope emerged with a Martian rock that reached Earth as the ALH 84001 meteorite discovered in Antarctica in 1984. In 1996, US researchers believed they had found traces of fossil bacteria on the rock, though later studies suggested similar structures could arise chemically. During its 6-year mission, the Mars rover Curiosity detected thiophenies, complex organic hydrocarbons almost always of biological origin on Earth. These ring-shaped compounds are common in coal tar and petroleum, byproducts of organic degradation. Researchers from the Technical University of Berlin have studied potential pathways for their formation, leaning towards organic origins given their prevalence and simplicity. This suggests Mars may have once harbored conditions conducive to life, although alternate chemical origins are also plausible, such as through sulfate-containing substances heated by meteorite impacts. Ultimately, we're left with uncertainty. Specific answers elude us. Yet, mounting evidence suggests Mars might have once teemed with life. It's conceivable that millions of years later, it's reduced to rock, sand, and deserts. Looking ahead, scientists paint a similar future for Earth, a distant echo of its current state, stripped of much of our civilization. Will we migrate to another planet? Perhaps. If Earth becomes uninhabitable due to solar warming, Mars or another world could become our refuge.